Okay, what I'm going to do here, just giving you guys a little bit more practice, is go through and explain some more with radicals and complex numbers. So if I'm given this first problem and I am going to reduce that radical. So I want to think perfect squares. What perfect squares will go in that? Um, I start 4, 9, 16, 25, 36, 49, etc. I like to find the biggest one. I know that 36 times 2 is 72. So square root of 36 I know is 6. I do not know the square root of 2. Now, if I would have done 4, well, 4 would have gone in there 18 times. Well, then I know the square root of 4 is 2, and I have the square root of 18. But then I have to look at the square root of 18, and 9 goes into that 2 times. So then I would have 2, square root of 9 is 3, square root of 2. I still get 6 radical 2. Second one, if I have a radical times a radical, don't try to break each one up, multiply it. Square root of 10 times square root of 12 is square root of 120. Now reduce 120. So you're thinking what perfect square goes into 120? Well, 4 will go into 120 30 times. The square root of 4 is 2. You don't know the square root of 30. No perfect square goes in to the square root of 30. Fractions. If I have a fraction to start, just split it up, a radical over a radical. Don't start changing that yet and thinking, oh my gosh, I gotta multiply by, look at them. Are any of them perfect squares? 25 is 5. Square root of 11 is square root of 11. You just can't have a radical at the bottom. This one, I split up square root of 3, square root of 7. But I don't know the square root of 7. So I have to multiply by itself. Whatever I do to the bottom, I do to the top. A radical times a radical is a radical. So I would have that. Square root of 21 is square root of 21, but now the square root of 49 is 7. If I gave you, just because I could, one where you had like 3 over 2 plus radical 5. So if I give you something where you have a 2 terms, you have to use the conjugate. So the conjugate of 2 plus radical 5 is 2 minus radical 5. Now you multiply. On the top, 3 times 2 is 6. 3 times radical 5. 3 is outside, radical 5 is inside. It's like an x. It's 3 times radical 5. That's done. Do not do 6 minus 3. 3 radical 5 is connected. So then on the bottom, 2 times 2 is 4. 2 times negative radical 5 is negative 2 radical 5. Now I'm going to take radical 5 times 2. That's positive 2 radical 5. And a radical 5 times a radical 5 is a radical 25. Those go away, but radical 25 is 5. So 4 minus 5 is negative 1. So I use the conjugate. So then, complex numbers. Really, with the big thing you want to remember is not even knowing really what this I is yet, just knowing that we are going to have imaginary numbers in Algebra 2. It really comes up with quadratics. So we just want to get it done with now, know how to work with it. If you are adding or subtracting, think of x's put together like terms. Adding parentheses mean nothing. So if I'm going to add that, I'm going to do 8 plus 4, 12. A positive 5i plus a negative 2i is a positive 3i. Subtraction, again, I would say just like polynomials, I distribute my negative, which means I take the first thing, I leave it alone. That positive 5 inside becomes a negative 5. A negative 6i becomes a positive 6i. Remember that subtraction is adding the opposite. Now, parentheses are gone. Just do it. 7 minus 5, 2. A plus 3i plus 6i is plus 9i. You're done. When you add, subtract, multiply, divide complex numbers, your answer is a complex number. So multiply, you know you're multiplying and you're not adding or subtracting because they are right next to each other. You distribute 4 times 7, 28. 4 times a negative 2i, just like an x. 4 times negative 2, the I stays. Think of I as 1i. 1i times 7, 1 times 7 is 7, the I stays. 1 times a negative 2 is a negative 2. But an I times an I, think of exponent rules. You add their exponents, it's I squared. So then we have to remember with multiplication, I squared is negative 1. If you multiply a number times negative 1, all that happens is its sign changes. So if I squared is negative 1, that means that that goes away and changes the sign of the number in front of it. Now combine like terms. That I squared is gone. So it's gone. It's just 2. 28 plus 2 is 30. A negative 8 plus 7 is a negative 1i. So I get just an I. Dividing is like the thing with the radicals. You use the conjugate of the denominator. So the conjugate of 5 plus 3i is 5 minus 3i. Whatever I do to the bottom, I do to the top. On the top, I'm distributing 4i. 4i times 5 is 20i. 4i times a negative 3i. 4 times negative 3 is negative 12. I times I is I squared. Do the bottom. 5 times 5, 25. 5 times a negative 3i, negative 15i. 3i times 5, positive 15i. 3i times a negative 3i, 3 times negative 3 is negative 9. I times I is I squared. Now, you guys should sort of see that anytime you use the conjugate, the middle terms cancel out. So now we have to deal with the I squared. I squared is negative 1. It goes away changes the sign of the number in front of it. So 25 plus 9 is 34. But I also have to deal with the top. I squared goes away, changes the sign. So I have 20i plus 12 over 34. Now, this could be reduced if all these numbers are divisible. They all have to be divisible by a given number, like 2 goes into all of those. You can divide everything by 2 and reduce. Now, if it doesn't work for all, then you don't do it. So then the only other thing that we talked about Friday, plotting. So just me sort of giving a generic picture. This is my real axis. This is my imaginary axis. So if I ask you to plot 4 plus 5i, it's a positive 4 on the real, a positive 5 on the imaginary. I go right 4, up 5. If I said negative 2 minus 3i, I go left 2 on the real, down 3 on the imaginary. And then the other thing that a lot of people forget about, if I went like that, you think you're like, oh, that's absolute value. Remember that absolute value is the distance from 0. So if I'm asking you how far away is 4 plus 5i from 0, the easiest way that I say to do that is draw a triangle and think that's 4, that's 5, Pythagorean theorem, a squared plus b squared equals c squared. So that would be 16 plus 25, 41 is c squared, which means c is radical 41, which would be that distance. That is called the magnitude, but really think of it as absolute value. We don't want decimals, reduced radicals. If that would have been like 40, you would have wanted to reduce that radical. So hopefully that helps, just to see another quick little lesson. We'll see you tomorrow.